So today we're looking at two more functional groups, carboxylic acids and esters. The functional group of a carboxylic acid is a carbonyl group, a C double bond O, and a hydroxyl group, an OH, bonded together. So this is going to be always at the end of a parent chain, and we call this a carboxyl group. So it's a C double bonded to an oxygen and then an OH. So we can represent carboxylic acids differently. Here we have in the condensed structural formula, here's the C double bonded to the O and the OH. Here's the line angle formula. Here it is condensed even more, COOH, that we see sometimes written that way. When we name a carboxylic acid, the IUPAC name replaces the E in the alkane name with oic acid. So we change the OIC as the ending. And then we number substituents again and name them. The carbonyl group, carbon, is always going to be carbon number 1. If we have 4 or less carbon atoms, we generally use common names. So here are some examples. Here we have methanoic acid, 1 carbon, methyl or methane, and methanoic acid. And here we have propanoic acid, 1, 2, 3 carbons, and on the second carbon we have a methyl group, so 2-methyl propanoic acid. Here we have butanoic acid, 1, 2, 3, 4 carbons with a chlorine on carbon number 3, so 3-chlorobutanoic acid. This is ethanoic acid, 1, 2 carbons. The common name for ethanoic acid is acetic acid, and that gives us the sour taste in vinegar. So the first 4 carboxylic acids have both an IUPAC name and a common name. So methanoic acid is known as formic acid. Formic acid is the acid in ant bites, if you've ever been bitten by an ant. Ethanoic acid, of course, is the acetic acid we find in vinegar. Then you have propanoic acid, propionic acid, and butanoic acid, butyric acid. So common names and IUPAC names as well. If we have a benzene ring, that aromatic ring, then we call that benzoic acid, and then we number the carbon of where the carboxyl group is bonded as carbon number 1, and then number the any substituent groups. So here we have benzoic acid. Here's the benzene ring. Here's the carboxylic acid part. So again, here we have the carboxylic acid part with carbon number 1. So carbon number 2, 3, 4. So 3, 4, 3, 4 dichlorobenzoic acid. So looking at this carboxylic acid, we're going to look and see what the different what do we got going on here. If I look, I see I have 4 carbons, 1, 2, 3, 4 carbons. I have a methyl group substituent, and then here's my carboxylic acid. So looking for the longest chain, that is butane, so that's 4 carbons, and we changed the name to OIC acid, so butanoic acid. And then carbon number 1 here, carbon number 2 would be the methyl where the methyl group is located, so it would be 2-methyl-butanoic acid. Let's practice a few more here. We're going to give the IUPAC name. So here I have 1, 2, 3, 4, 5 carbons. 5 carbons is pentane. So then this one would become pentanoic acid. So the ane becomes OIC. So the second one down here on B, I see that is a benzene ring with the, so here's my benzene ring. I see there are a carboxylic acid group, so that is known as benzoic acid. And then I number my carbons. This would be carbon number 1, 2, 3. So this is a 3-chloro benzoic acid. The second group we're going to talk about today are known as esters. Now, don't confuse these with ethers, which we talked about previously. So esters are formed from a carboxylic acid and an alcohol bonding together. So in an ester, they have an alkyl group, a chain, attached to the single bonded oxygen atom. So here we have a carboxylic acid, ethanoic acid, 2 carbons, acetic. And then here's the ester with a methyl group attached to it, and this is known as methyl ethanoate. So we'll talk about the naming here in a minute, but you can see it's a carboxylic acid with a carbon chain attached to the oxygen, the single bonded oxygen. In a reaction called esterification, an ester is produced when a carboxylic acid and an alcohol are generally heated with a strong catalyst. The catalyst is usually an acid like sulfuric acid. So here we have acetic acid. Here's my 2 carbons with the carboxylic acid part. Here I have methyl alcohol or methanol, 1 methyl group, and then my OH. And then what happens is the H and the OH bond together, are removed, and then what we get over here is the O and from the alcohol bonds to the carbon from the carboxylic acid, and then we get just plain old HOH, which is just water. The name of an ester has 2 parts. The first word is the alkyl group from the alcohol, so this part coming from the alcohol. And the second part is what was the carboxylic acid part. So here we're looking at IUPAC names and also maybe some common names. But let's look at the IUPAC name first. So here we have, here's the alkyl group from the alcohol, and here's the acid part. So then looking at the name, so that's the alkyl group is a 3-carbon chain, 1, 2, 3, and that's propyl. Then looking over here, I have again 3 carbons, right? So 3 carbons would be propanoic acid, right? So we change the IC acid to ATE. So we get this propanoate acid. Propyl propanoate is the name of this ester. So looking here at another example, here we have the alkyl group from the alcohol, and that would be then 2 carbons, so that would be an ethyl. Then over here is my carboxylic acid part, numbering its carbons 1, 2, 3, 4, 5, 6, 7. So that's heptanoic acid. So we would name it heptanoate, ethyl heptanoate. So from heptanoic acid to heptanoate. So then looking at the second one, here again is our alkyl group. So that becomes a methyl. And then here is my carboxylic acid part. Counting its carbons, I've got 1, 2, 3, 4, 5, 6. 6 carbons. So that is hexanoic acid. So it becomes hexanoate. Esters are found lots and lots of places in fruits and flavorings. They give lots of flavors and odors to different kinds of fruits. Pears, bananas, oranges, pineapples, apricots, different kinds of fruits all have esters in their composition to give them that flavor and that odor. Butanoic acid reacting with methanol. So here we have butanoic acid reacting with methanol. Gives us methyl butanoate, which is the ester found in pineapples. So lots of different places to find esters. We see a lot of carboxylic acids. We've used vinegar a lot. Carboxylic acids are important in the cellular respiration and the citric acid cycle, or the Krebs cycle part of the reactions there. But we get lots and lots of different kinds of reactions with these things.